Okay, we are going to do a quick lesson on volume. And so since we're doing this in a video, I am going to try to not get on my soapbox and ramble about things that are less important. And I'll save that for when I'm actually in front of you. So I need you guys to find lesson 3 in your packet. Mine's in color, yours not. Haha. But I want to talk about volume. And as you're finding it, this is just a reminder that we can use multiple integrals to find volume. And it's kind of like finding the volume of a potato by figuring out how big all the French fries are and then adding them all together. So if we look at this, I say, hey, look at that. I have a potato, or at least, 1/8 of a potato right there. And then this mesh netting stuff down here is you can think of that as like the fry slicer. And I know that's ridiculous, but I'm trying to give you an analogy here. Just go with it. So if we take that fry slicer, we have one French fry, and then we have all the fries. And so if I want to find the volume, I can find the volume of each individual fry and then add them all up. So for example, let's say I have a pile of dirt, okay? I picked dirt because it's brown. So let's say I want to find the pile of dirt right here and figure out its volume. Well, that's obviously not a regular shape. So what we can do is we can slice it into little sections, and each of these sections is 10 yards by 10 yards. So 10 yards across and 10 yards out. And then the heights I've measured at each individual location. Well, I didn't, somebody else did, and it's pretend. But all of these things are in 10-yard units. So right here, I have 7 10-yard units, okay, and then 9 10-yard units and 10 10-yard units. This is a big pile of dirt, guys, like just a huge pile of dirt. But anyways, if these are each of my given heights, I can say the volume for this one piece right here is going to be 10 by 10, because that's my base, times 7, which is my height, right? So 10 by 10 by 7, which is going to be 700 um, cubic 10-yard units. If that makes a little bit of sense here, but I feel like the easier way to go is to say that really number one, if that's a 10-yard unit, is 100 times 100 times 70, which makes it a 7 with 1, 2, 3, 4, 5 zeros. So it's 700,000 cubic yards. And then we'd find the volume of number 2 and number 3 and number 4 and so on. Except obviously we're not going to do this one at a time because that's ridiculous. So what we're going to do instead is say, you know what? All of those bottoms are 100 by 100. And then all of the tops are the sum of all of those things. And each of those will get multiplied by 10 because they're 10-yard units. So if we come through here and find the sum, let's see, 10, 17, 17 plus 9 is 26. That's 16 plus 10 is another 26. And there's 11 plus 7, that's 18. So 100 times 100 times 26 plus 26 plus 18. That's going to be 52 and 18 is 70. So 100 times 100 times 70 times 10. Forgot my times 10 with this guy because they're 10-yard units. And look at that, we got another 7. That's a coincidence. So I have 7 with 1, 2, 3, 4, 5, 6 zeros now. So that is 7 million cubic yards. So much dirt. Like an insane amount of dirt. But there you go. If you want to find volume, you can do length times width times height to get volume, which leads us to the volume formula using a double integral. So here's why this makes sense. When I do this double integral here, my integrand is f of xy dA, where f of xy is your height, and dA is either dy dx or it could be dx dy. Whatever order you want, you can change it at will and as necessary. Well, dx dy and dy dx really used to mean delta x times delta y. That's equivalent to this 100 by 100 we did before. And then we took that 100 by 100 and multiplied by the height. So long story short, this is volume because this is really length times width. And then over here is times height. And if I add all that up, I'm going to get my volume. Okay, so if you want volume, your height goes in your integrand, and then dx dy in whatever order you need. Got it? Good. Of course you do. So in example 2, it says calculate the volume of the solid region bound between this thing and on the region R given by 0 to 1 and x and y. This one, super simple. I make my double integral. My integrand is 1 minus 1/2 x squared minus 1/2 y squared. And then I have dy dx or dx dy. I'm not sure yet. So how do you pick the order? Number one, you look at your integrand. This integrand can be integrated with respect to x or y first. It doesn't matter, so we leave it there. Then I look at my region. Well, my region is 0 to 1 and 0 to 1. That's vertically and horizontally simple, which means it doesn't matter which order I go in. And I usually say if nothing else matters, go for dy dx. So my y bounds are 0 and 1. My x bounds are 0 and 1. And then we're going to integrate it. So So let's integrate it. With respect to y first, that makes it y minus 1/2 yx squared minus 1/6 y cubed from 0 to 1. And then if I plug in 1 for y, I have 1 minus 1/2 x squared minus 1/6. And then I'm integrating that with respect to x. And unless I tell you otherwise, once you get down to a single integral, please feel free to put it in your calculator. So, come on, calculator. Let's go. Oh, I'm tired just waiting for this thing. 1 minus 1/2 x squared minus the sixth. So, that's 0 to 1. 1 minus 1/2 x squared minus 1/6. Nope, that's a 9. That's a 6. Dx. 2/3. There you go. 2/3. That's your volume. Then it says calculate the volume of the solid region bound between the plane 2 minus x minus 2y and the xy plane in the first octant. So now they didn't give me any information about the region. Okay, so I need to figure out what is this region right here that I'm going to integrate over. So this thing down here is my region. All right, well, I know that my double integral is going to have a 2 minus x minus 2y because that's my height. But I don't know if I want to do dy dx or dx dy, so I'm going to leave those d's blank for now. And I'm going to come back over here and sketch my region. So let's see, it's taller in x than it is in y. So that blue region right here looks like that if I look from the xy plane perspective. It'd be really nice if I knew the equation of that slanty oblique line. Well, I do. If I'm on the xy plane, that means z equals 0. So this line right here comes from 0 equals 2 minus x minus 2y, which is 2y equals 2 minus x, which is y equals 1 minus x over 2. And if that's 1 minus x over 2, this goes from 1 to 2. All right, now I can decide my order of integration. My integrand can be integrated with respect to x and y equally. My region R over here can be integrated. It's both vertically and horizontally simple. So I'm going to go with dy dx. The nice thing about going dy dx is that your first set of boundaries are in y equals form. So my top boundary is 1 minus x over 2. That's this thing. And my bottom boundary is the x-axis. So that's y equals 0. And x is shaded from 0 to 2. So now if we want that volume, my integral with respect to y is 2y minus xy minus y squared from 0 to 1 minus x over 2. So 2 times 1 minus x over 2 minus x times 1 minus x over 2 minus 1 minus x over 2 to the second. And then when I plug in 0, everything goes to 0. And now I got to throw this thing into the calculator and get an answer. And you might think maybe I should just say, it's something, but I have a plan here. So I want to do the integral from 0, to 1 of 2 times 1 minus x over 2 minus x, 1 minus x over 2, and then minus 1 minus x over 2 squared. 0.583, and that really wants to be a fraction, so let's let it. 7/12. 7/12, everybody. Now, I think that's correct. So what did I want to do this? There was a plan here. What was my plan? Oh, I know. So my plan is, hold on, I have to pause this for a second. I paused it because I knew that was not the right answer, and I couldn't figure out what I did until I just paused it and looked really closely and realized this should have been a 2 the whole time. So my apologies. I need you to fix that and make that a 2. And if we make that a 2, our answer is going to change just slightly. So if I come back up here and I snatch that again, enter, this can go away. Da, 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 da. And I make this 2. There we go. That answer is 2/3. Fantastic. That's what I wanted. So this should be 2/3. Sorry about that. Arithmetic. Arithmetic and carrying problems. Okay, so why did I care so much? I cared so much because there's an easier way to do this that is worth bringing up. This thing right here is a tetrahedron, and the volume of a tetrahedron is 2/3 the area of the base times the height. So 2/3 the area of the base times the height. Ah, or I mean, ah, um, so it's 1/3. So the volume of a tetrahedron, it has also a much easier formula, and that volume is 1/3 the area of the base times the height. It's really the volume of a pyramid. And so if I look at that base down there, that would be 1/3, 1/2 of 1 times 2, because that's a triangle. And then the height is where this would hit the z-axis, which is when x and y are both 0. And my height would be 2. So 1/3 times 1/2 is a sixth. A sixth times 4 is 4/6, which is 2/3. And that's a heck of a lot easier than going through all the integral stuff. So I just wanted to show you both ways. Okay. Last but not least, find the volume of the solid whose base is the region enclosed by y equals x equals 1, y equals 0, and whose height is determined by e to the negative x squared. So I know I'm going to have an e to the negative x squared as my integrand, and my differentials are going to go dy dx or dx dy. Well, here's the thing. You can't take the antiderivative of e to the negative x squared without a Taylor series, and we all know how much you guys love those. So we have to do dy dx here because I can't integrate with respect to x first. So then I'm going to come back here and redraw my region, which is y equals x equals 1, and y equals 0. So there's my region. So from top to bottom, it goes from y equals x to y equals 0. And from left to right, it goes from x equals 0 to x equals 1. And then my antiderivative would be y e to the negative x squared from 0 to x, which is going to be x e to the negative x squared minus 0 dx, which is math 9, 0, 2, 1. Come on. X e to the negative x squared dx 0.316. And there is your answer. So, long story short, here's what I need you to know. When you set up volume, it's just your hovering surface that's creating the volume becomes your integrand, and then your region of integration creates your boundaries. When you're setting up the integral, consider which order of integration is best. You want to think about that. And if the integrand is integrable with respect to both x and y, then you use your region to determine which one you want. Go for dy dx if nothing seems to matter. Just trust me on that. Okay, so there you go. This is as long as it needs to be. Um, Hopefully it makes sense. See you later. Where is my stop button? There's my stop button. Bye.